I could do a few. I was fun, but there were also a few that I just like did not really know what I was doing.
Right.
I mean, it probably would help me if we were like practicing. I know we had to go over the homework. We didn't do any really well.
Which is kind of what we need to do in class, but if I work all the homework problems, we don't have time to do that, right? So we need that practice in here too. I just don't want y'all giving up. I don't want you overly stressed, but I don't want you looking at it going, oh, it's just too hard, and then you give up. And then you watch me do it, and because I know how to do it, it looks easy, and then you go, oh, yeah, that's easy. Of course I know how to do that. And then we're back where we started. Okay, so anyway, enough of that. Yeah. Okay. Like 15. Okay, so I can already tell you why a lot of you did not know where to go on this. You said 15? Because you're not remembering the algebra.
I didn't know if I needed to.
Go ahead.
I was getting confused. I didn't know if I needed to change it or something, like take a derivative, or if I needed to factor it as equal to zero, take something out, plug in. I didn't know. Yeah, like I didn't know.
Okay, so you could do this algebra way. You could do it calculus way. I would probably say on this one, I don't know, whichever way you. And what did you do with the derivative? Why? Right. Right. Did everybody hear that? If I'm all right, first of all, this is a quadratic, yes? This is the max height, yes? What's happening there in terms of calculus? The slope and the slope, what happens here? It equals 0. We talked about that, right? When it changes, that's when it's 0. So I could look at this algebra 2 wise and go, well, how do I find the vertex of a parabola? Opposite b over 2a. What's your question? What you saying? But one of the t's would be what? But that's if you do this equal to 0. This is position. So that says at time t equals 0, the height is 0, which makes sense because it shoots off from the ground. And then the other solution would be this other end of it. But that's not what I'm looking for because it asks me about a maximum height. How high would the rock go when you throw it? So if I do the derivative, it's asking about height, so you have to understand what it is it's asking you about. What happens? How do you find the maximum of a function itself? Think about if, yes, it's velocity, but think about if I had, when you were graphing the function versus the derivative graph, right? You understand what I'm saying? When you were doing, if I had something like this and I said graph the derivative of that, so if this is, we'll just call this f of x. If this was the derivative, what happens here? What does it look like? It looks like a line, right? Negative and then positive. And it crosses over right where this is high. So it looks something like this. Positive, oh, sorry. Right? So where does this maximum occur? Well, I can find that with calculus by just doing the derivative, which is this one, and finding where it crosses over. Well, you're fixing to have some that you won't be able to. This is an easy example. This is an easy equation to show you how to use calculus. Does that make sense? So what if I had this really nasty function? I could apply the same thought process. Is why they're doing it this way. Okay, so in other words, I come here, I go 24 minus, what's 2 times 4.9? 9.8 t. Where does that equal 0? Twenty what? Oh yeah, I did the derivative. Okay, and this is in meters, right? So this point, how do I know that it's a maximum? Well, remember that little sign analysis that I showed you yesterday? If this is the derivative, it tells me what the function is doing. So the 0 happens at 28.3, 29, 29.3, sorry. The sign of the derivative less than 29.3, so this equation, is it positive or negative? Positive? Oh, what is it? What's it give you? What is that? Yes, yes, that's the time it happens. That's your variable t. Seconds. Right, right, right.
Like I didn't know.
So 2.44 seconds is when it, does it say when it happens or how high it goes? How high would it go? So then I have to plug it back in. So if it happens at 2.44 seconds, so yeah, this should be 2.44. Sorry. What did the derivative give me? Well, the derivative gives me where it's 0 so I can find maxes or mins. Right. Let me try this. Let me say, see if this will help you. To find max or mins with calculus. Find the derivative first. Set it equal to 0 and solve. And then do a sign analysis. I think the sign analysis will help you more than anything else. Okay. Let me run through one start to finish with the sign analysis and show you what it does. Yeah. 2.44 is how long it takes to get there, right? That's going to be your derivative. That'll give you velocity. What does it ask you for? The height. Height is a position, so it always goes back to that original. So you have to carefully read what they're asking you for. No. Oh, yeah, from there. The derivative of velocity, acceleration. But this is the second derivative of position. So this is position, or where it is, where he is on the number line, what his height is, anything like that. Position, velocity, acceleration. You won't have a hard time with that. We'll do it so much, it'll be ingrained. PVA. That's why I keep saying PVA. Position, velocity, acceleration. Absolute value of velocity is speed. Remember too, I knew you would, this is a big, big, big chunk. So it's going to be difficult. This is where it's a challenge. But once you get it, you got it. We are the diesel instantaneous rate of change. Position, velocity, acceleration. Well, so these are the applications of the derivatives. So now that we've learned enough of the derivatives here, we kind of pull this. Instead of doing all the word problems and all the applications at one time in one unit, it's easier. I think it's better to put it to the one of those. Okay, so let's apply what we know. Which one did you say? 15? 14? 16? All right, let's read through it carefully and let's see what it is they're asking us for, okay? S equals 832t minus 2.6. I'm going to leave you some of these practice to do tomorrow in class too when I'm not here. I mean, I'll be up here, but I've got to do some observations up here. I won't be in here. I might can stick my head in for a few minutes if y'all have some. All right, this is 16. A bullet fired straight up from the moon's surface would reach a height of this. So again, this is a parabola. Okay. Okay, but look, this has got two different things. This is moon, Earth. How long is your T? Yes. Okay. Yeah, that's what I would do there. I would do it algebraically. To me, this is not a calculus question at all. It does. So I had one student last year, she did her homework every night. That's the way she did. She drive me crazy going, I looked at the solutions, but every night that's what she did, and she figured it out. She ended up making 4 on the exam. She did really well. But yeah, the solutions really do help. Yeah. No, it has all of them. No, I posted the teacher solutions. This is 2-4. Did they not do it out? They didn't do it with algebra. They did it with okay. Your brother was at a meeting yesterday. He's so nice. Well, I had him like brainstorming different things that they could do. But my sister works at Pelicans, and I said, "Who's your sister?" I didn't even make a connection. He's so cute. How long would it take the bullet to get back down in each case? Well, 0 is one of them, but that's one of your zeros because that's where it starts. But then what's the other 0? You found this one. Not the only way is if you were given like the velocity equation move backwards on it on that. Yeah. Yeah. Right. This will be. You don't have to plug T in. Not these questions. These questions are different than the kind of word problems you're used to doing in math because it's not everyone is not asking for the exact same thing. You can't just memorize and go, okay, if it's a position equation, then I'm always going to do this because it's not always going to be like that. You really have to learn to interpret what it is it's asking you to do. What does it say? Read that last sentence. Is that height? That's just. How long did it take you to get to school today? It took me 5 miles to get to school today. Or you can just solve for the seconds to start with, since that's T. What's it? I haven't done